Hello, this is Professor Matt Katroulis at Rio Hondo College, and I'd like to welcome you to this, the first video for the Chemistry 110 lab here at Rio Hondo, with the focus of this experiment being on measurement. Before we get into the details of measurement, I would like to discuss how you should approach the lab so that you can get the most out of it and hopefully maximize your grade. So we'll talk about, first of all, what you should be doing to prepare for the experiment, what you should be doing during the experiment while the videos are playing, and what is necessary for submitting the lab report. Once I've finished that, I will start to discuss the experiment on measurement with a lot of focus on how to interpret measurements so that you can record them correctly. I'll then spend some time discussing significant figures, another important issue in chemistry measurement. Mixed in with a lot of that, I will talk about units and spend a little bit of time just talking about that subject on its own. And then we will look at the details involving measuring length, volume, and mass, which are the main topic of this experiment. You do need a few items in order to complete this experiment. First, you need a ruler, which has centimeter markings on one side. It will usually have inch markings on the other. And you need a piece of string, twine, or ribbon, because at one point you'll be asked to measure the width of your wrist, so you'll need something flexible that you can wrap around it. So first, let's talk about what's necessary for preparing for each experiment. In your lab manual, which you should have purchased at this point, you will see instructions for every experiment that we are going to perform. There will also, incidentally, be some experiments which we may not perform, so it's always important that you check the syllabus and schedule to see which experiments are scheduled for which days. You'll want to take a look at the course website to see if there's been any modifications that have been posted for the experiment. Some modifications will also be made in these videos, so keep your ears alert for that. Always read the introductory material at the beginning of each experiment and the procedures before watching each video. You'll probably get the most out of them if you have some idea what I'm going to be talking about in advance. Go ahead and make any notes or questions for anything which is unclear, which you see during the video, and hopefully those questions will be answered as we progress. You'll want to be sure to review any material in the lecture which seems to be pertinent to the lab that we are doing. And you'll also want to be sure to complete the pre-lab study questions for every experiment neatly, as well as in pencil, so that if there's any errors you can easily change them. If you have any questions that don't make any sense to you in attempting those pre-lab study questions, go ahead and attempt those after watching the video. Hopefully at that point most of those questions will have been cleared up. I will begin each of the experiments with a brief introduction. In some cases, each part of the experiment will have an introduction as well. You'll want to make sure that any of the questions that you wrote down earlier have been answered while you're looking at the introductory sections, and if not, hopefully they will be answered during the experiment itself. If not, you'll want to get in touch with the instructor to be sure to ask them. If any procedures are changed during the video, you'll want to be sure to make a note of it and cross out any necessary sections in the lab report. Very important, follow all instructions carefully. The main reason that you lose points on these experiments is because you didn't follow the directions. So please, I cannot overemphasize that enough. Make sure that you read all the instructions very carefully, and any instructions that are given in the video you pay careful attention to as well. You'll want to watch the video as the experiment is being performed, and where instructed you'll want to pause to record the data and any observations that are relevant. And you'll fill in the lab report neatly with dark pencil. Again, pencil so that it's easy to make changes as you go along. Make sure that you've completed all the questions in a part before you continue on to the next section. When you're done with the experiment, you need to be sure to review the entire lab report and make sure you didn't accidentally skip any portions. Sometimes questions will appear towards the top of a page or a bottom of a page, and students will just simply not see them and leave them blank, and that will cost points when I'm grading the experiment. You need to make sure that all the measurements that you write down have the correct number of decimal places, the correct number of significant figures, and have the correct units. That is probably more than anything going to be the subject of this experiment. If you are asked to show your calculations on the lab report, you need to make sure that you have done so. You'll want to follow the significant digit rules in all of the calculations. Those rules will be discussed in more detail in Experiment 2. Make sure that you've erased any markings that are not necessary so that they are not confusing to the grader. And then, using your phone, you'll want to take pictures of the pre-lab study questions and the non-blank sheets on the report sheet section. For example, with this being Experiment 1, if you go ahead and take a look at the lab manual, the pages that you will want to submit are pages 7, which contain the pre-lab study questions, and then page 9 and 10. Page 8 is blank, and I definitely don't need to see a picture of a blank page. And pages 1 to 6 are the procedures, and there shouldn't be anything written down in those that we would need to see when we grade them. You must submit these as a single PDF file, and all the pages must be in the correct order. So, for Experiment 1, that would be page 7, then page 9, then page 10. Do not submit separate files for each page. That makes grading a nightmare, and we may not accept the experiment in that particular situation. Also, you need to make sure that you look at the PDF file before you submit it to make sure that it has all pages, the pages are in the correct order, and that all of those pages are readable. From my perspective, this is the most important lab activity that we do this semester. And that is because ultimately what we're going to do in this experiment will be tested throughout the rest of the experiment as we take measurements. And it's important that you're measuring things correctly from the start so that you're not developing bad habits as we go along. So if we look at what's going to be covered in this lab, I'm going to spend a lot of time in the beginning focusing on how you should read measurements correctly. And this will include how to read rulers and meter sticks, reading the volumes on graduated cylinders and burettes, reading the mass on a balance, as well as reading temperature on a thermometer. Now, you should not assume that you know how to do this. In chemistry, we have very specific ways as to how that has to be done, and it is critically important that you follow the directions exactly as they are given in this video. From there, I'll discuss the differences between measured and exact numbers, and I will also discuss the very important topic of significant figures, which we talk about in this experiment as well as in the next one. It is vital that you not skip any of these slides or rush through any of this material. You want to make sure that you absorb as much as you possibly can from every slide that I present. So we're going to use the same techniques for all the measurements for anything which is not electronic. In other words, anything that does not give you a digital reading. What you do is you're going to start off by thinking of any measuring device as a number line. And in fact, I'm going to start with number lines because I think it makes an easy introduction. Before you try to read anything at all or interpret anything from the number line, what you need to do always is look at the markings and see what place value they represent. Now, when I'm talking about place values, I mean things like the ones place, the tens place, the tenths place, so all the different decimal places. So let's take a look at this ruler here. And the easiest way to do this is, first of all, you look to see if there's what lines you have. There's no small lines here in between. So if I'm counting here, 0, 1, 2, 3, what am I counting by? Ones, tenths, tens, or something else. So 1, 2, 3, 4. Every time I say a new number, I'm going up by 1. So these lines represent the ones place. What value am I indicating with this arrow on the number line? Well, let's talk about what we are absolutely certain of first. First of all, we have no question at all that the arrow is in between 2 and 3. And the number is then going to have to begin with 2, correct? Any number between here and about here would begin with 1. Any number between the 2 and all the way up to, but not including the 3, begins with 2. So I am sure that the number begins with 2. Now, when I look at its position between 2 and 3, it looks like it's about halfway between there, but you notice the difference. I'm not saying I'm sure. I'm not saying I'm positive. I'm estimating that it's halfway between 2 and 3. And the number that would be halfway between 2 and 3 would be 2.5 or 2.5, but we're going to stay with decimals here. So 2.5. And so what I'm going to say here is that the measured value is 2.5. And I'm not entirely certain about that last digit. So if I had someone else go ahead and read this measurement, they might say, no, I think it's 2.4. Or they might say, I think it's 2.6. And are they reasonable? Well, if I had to estimate, then they're doing the same thing. And I think we can all agree that it's near the middle of 2 and 3. 2.4, 2.5, and 2.6 are all near the middle between 2 and 3. So I would say that those are all reasonable. If someone said 2.1 or 2.2, yeah, I'd have a hard time with that. 2.1 or 2.2 would be much closer to 2. Just like if they said 2.8 or 2.9, that would be much closer to 3. So 2.5 is where I would go with. These others would be fine, and that's okay. That's totally fine and normal for measurements. So, as I said, I ended the measurement with 5, and others could have ended it with 4 or 6, which are nearby. Now here is the most important sentence probably in this entire set of videos, and that is that you are only allowed to estimate one digit, exactly one, in any measurement. And what we will call that is either the uncertain digit or the estimated digit. Either term is acceptable. Now, if I'm not certain about the 5, 2.5, then could I say 2.53? But I'm not sure about the 5, then I'm totally unsure about the 3. 2.537, you get the idea. I mean, you could sit and write numbers down all day long, but that doesn't make it any better of a measurement. The issue here is that you are ultimately stuck with only one uncertain digit. That's all you can have, exactly one. Okay, let's say we want to figure out what value is being indicated by the arrow. It's the same number line, so I'm still counting by ones. 1, 2, 3. So it's between 4 and 5. So I'm certain that it's going to begin with 4. But I'm not certain about the next digit. And remember, I can only estimate once. It's very close to the 5. So I would say a reasonable answer would be 4.8 or 4.9. And as I said, we are absolutely certain about the 4. So there's no question there. And I had to estimate that last digit, and so it is uncertain. Notice I didn't necessarily say it is definitely 4.8 or it is definitely 4.9. I can't. It's a measurement. So I would probably write down 4.9 in this case. So any non-electronic device, in other words, anything that doesn't give you a digital reading, you can always figure out which decimal place is going to be uncertain in advance. And remember, the first thing I asked you to do was to always look at the markings. So this is essentially what we're going to be doing here. Look at the smallest markings, and we'll notice that the only markings here again are ones. Your measurement will always go one decimal place to the right of whatever you said those markings were. So if the smallest markings are ones, the answer using this number line would always go to the tenths. There is no exception. That does not change. If you use this same number line, your answer will always go to the tenths. And that last digit, the tenths place, is your uncertain digit. What is the value that's being represented by the blue arrow? I think it's clear that it's between 1 and 2, so I'm certain of the 1, and as I've already said, since this is the same number line, we must go to the tenths place. This looks really close to 1, and from my perspective I would call that 1.0, but I'm sure other people would say 1.1. Either of those are reasonable and acceptable answers. Certainly 1.5 is not reasonable, because 1.5 would be right in the middle, between the 1 and the 2. What is the value represented by the red arrow? Well, that is right on the line. And let me warn you, this is where students are most likely to make errors, when they have a measurement on the line. If it's right on the line, I still can't say it's exactly 4, because I'm always estimating. I could always try to blow this up even better and get a better idea, and I might see that it's not perfectly on the line. I'm still estimating that it's right on the line. The idea here is, if I wasn't positive about the blue arrow, I really can't be positive about the red arrow either. So what I'm going to say here is, I have to give my answer to the tenths place. We've already decided that. So if it looks like it's right on the line, I write 4.0. That is by far the best answer here whenever you have something that's on the line and you know you have to go to the tenths place. Technically, 3.9 is reasonable, although I would personally have a very hard time taking that. And technically 4.1 would be considered reasonable, but 4.0 is, I think, what almost anybody would say taking a look at this situation. So if you wrote 4, that would be considered incorrect. 4.00, incorrect. All of these are incorrect. 4.0 is what you need to have because it's going to the correct decimal place. Alright, let's change up our number line a bit. So now I've changed what these markings are. If I go ahead and I count by them, 0, 10, 20, 30, I am counting by, instead of ones, I'm counting by tens. So the only markings that we see are tens. So what is going to be the uncertain whenever we use this number line? Remember, we said look at the smallest marking, and then you go one decimal place to the right of whatever those markings are. So we said the markings were tens. One decimal place to the right of the tens is the ones. So that is where all values would go for this number line. Every one of them must go to the ones place. No exceptions when using this number line. So let's practice. What is the value indicated by the blue arrow? Well, it's between 10 and 20. So I'm certain of a 1 being in the tens place. So it's going to be somewhere between 10 and 20. Definitely sure that there's a 1 in the tens place. It's quite a bit closer to 10 than to 20. I'm not quite sure if it's 11, but I would tend to go with 11 or 12. And those are both reasonable answers. Now some people will say, oh, but Professor Katroulis, you've been saying tens place, tens place. Yes, I was saying tens place, but that was for a different number line. This number line has tens as its smallest markings, so therefore we go to the ones place, 1 decimal place to the right. How about the red arrow? The red arrow is between 30 and 40, and it looks like it's about halfway in between. So halfway in between 30 and 40 would be 35. 35 goes to the ones place, and to me that's the best answer. But 34 and 36 would also be reasonable choices, and I would not consider those incorrect. And then what value is indicated by the yellow arrow? That might be difficult to read there. Well, it's right on the line, so I think it's pretty clear to most anybody that looks at it that it's 50. Again, it's not exactly 50. We're estimating, just like we did for all the others. And we have to show that it goes to the ones place. And so 50 with a decimal point is the best choice. And the reason for the decimal point is it basically tells us that we estimated at the ones place. Without it, it would tell me that I estimated at the tens place. And that's something I'll talk about more a little bit later on significant figures. But for right now, 50 with a decimal point would be the right answer. Same idea, if we were right on the 40, it would be 40 with a decimal point. It's ending at the ones place. Okay, what is going to be the decimal place of the last digit, the uncertain or estimated digit on this number line? Same procedure as always. Don't even look at the arrows. You first want to start by looking at your markings. So 0, 0.1, 0.2, 0.3. Or if we read this mathematically correctly, this would be 0, 1/10, 2/10, 3/10. I'm counting by tenths. So what does that mean our answer goes to? Not the tenths. 1 decimal place to the right of the markings. So the decimal place to the right of the tenths is the hundredths place. So we will always go to the hundredths place using this number line, and so for all 3 of these arrows they must end in a digit in the hundredths place. Okay, how about here for the blue? It's definitely going to have a 1 in the tenths place. I'm not sure about the hundredths place. I have to estimate. It looks a lot closer to the 0.2 than it does at the 0.1. So I'm thinking it's going to be 8 or 9. Looks like it's halfway in between. So I'm going to say ultimately here, let's say 0.19. But again, these are both acceptable answers. Remember, I can't say 0.185 and say that's halfway in between, because if I'm not certain about the hundredths place, I can't go any further than that. And the way we're writing it like this is telling the person who's looking at the measurement that you were uncertain about the hundredths place. How about the red arrow? Uh-oh, we're on the line again. So these are ones that people tend to make a mistake about. So be very vigilant. Remember, we are going to go to the hundredths place. So 0.30. That's it. Incidentally, that first 0 that's written there, it's just a convention to draw a 0 in front of the decimal point if there's nothing in the ones place. I believe that the reason for that is so that it's clear that the decimal point isn't just some accidental splotch of ink. So we're making it very clear here that that is a decimal point. And then how about the yellow arrow? Well, I'm very sure it's going to be 0.5 something. So there's definitely 5/10. How many hundredths? 1 or 2. I'm not sure. So I would say 0.51 or 0.52. Either of those are acceptable. So what I would like you to do at this point is take a moment and take out a piece of paper, and I would say number it, but because you're already going to be using numbers, I'll say I want you to letter the paper. So A through O, A, B, C, D, E, etc. And what I want you to do is you look at each one of these sets of questions. So A through E is one set of questions, and then F through J is another set. So first, you want to say what decimal place your answer should go to for estimating on B through E. Okay, and so again, you look at the smallest markings, and remember you go one decimal place to the right of whatever those markings are for that particular number line. You'll notice that each of these number lines is somehow different from the one above it. So that means you might end up with a different answer. You might end up with the same answer in terms of decimal places. That's possible too. But I need you to always answer that question before you attempt a measurement. So look at the decimal places, and then for B, you would say what you think the correct measurement is, and C, what you think the correct measurement is, etc. Now later on we're going to add units to this, but for right now we just want to give numbers. So please pause the video. Try to attempt every one of these questions to the best of your ability. Be very, very careful about decimal places. And then when you're ready to go on, unpause the video and we will go through these. Okay, I'm going to assume that at this point you have paused the video and you have written down answers for every one of these. Don't skip doing that. Don't be tempted. Make sure that you've attempted this. So let's answer question A. What decimal place should we report our answers to for B through E? Well, if we're looking at the ruler, we're counting in ones. 1, 2, 3, 4. So therefore you go one decimal place to the right of that. That would be the tenths place. And that's going to be true for all of these measurements, B through E. So B is about halfway between 0 and 1. So it's going to be 0 point something in the tenths place. And if it's halfway, I would say 0.5. 0.4 also seems reasonable. Now I'm not always going to give two possible choices here, but you can almost always assume that you can be 1/10 either side, and that would be acceptable. For C, I'm going to say 1.9. It's halfway, I mean not halfway, it's much closer to 2, and it definitely begins with 1. 1.8 would be fine as well. D. To me it looks like it's right on the 4 line, and so it's not going to be 4, it's 4.0. We're always going to the tenths place with all of these measurements. And then E definitely begins with 5. I'm inclined to say 5.2 when I look at this. Some people might say 5.1, and some people might say 5.3 even. But I think 5.2 is the best answer, and any of those would have been acceptable. Now we move on to another number line F. And we again look at the smallest markings, 27, 28, 29. I'm counting by ones. So if I'm counting by ones, that's the same thing that I did in ruler A. I was counting by ones. So I will estimate one digit to the right of the ones place, the tenths. So all of these will also go to the tenths. G looks like it's right on the line, so it's going to be 28, but I have to go to the tenths, so 28.0. H looks like it's halfway between 29 and 30, so I would say 29.5. I essentially looks like it's on the line there, so I need to go to the tenths. That would be 30.0. However, I think someone could reasonably make the case that that is 29.9 because it is a little bit off of the 30. It looks a little to the left, but to me, I see this mostly as 30.0. And how about this one, J? It looks to be a lot closer to 32, but it has to begin with 31. So 31.8 or 31.9 would be acceptable answers there. Now, how about K? What decimal place should we go to for L through O here? Again, we start by counting these numbers here, so 1.8, 1.9, 2.0, or we could say that's 1 and 8 tenths, 1 and 9 tenths, 2 and 0 tenths. So we're counting by tenths. If we're counting by tenths, then we go one decimal place to the right, and that would be the hundredths place. So for L, we need to be really careful here. We know it's going to begin with 1.8. Now we just kind of estimate how far along is it. So this would be 1.80, right about here would be 1.81, 1.82, etc. So to me this looks probably about 1.87, maybe 1.88. I'm mentally dividing it in my head into about 10 intervals, and to me that looks like it would be right at about 1.87, the seventh one or so. But either of those are fine answers. M. 2, but not 2.0. It's on the line, and this line we said here always goes to the hundredths, so it's 2.00. The same thing applies for N. It looks like it's right on the line, so it's not 2.2, it's 2.20. Always going to the hundredths on this number line. And then O, well, O looks about the same distance to the right that L was compared to 1.8. Maybe it's not quite as far. So this is going to definitely begin with 2.3, so 2 and 3 tenths, and then I'm going to say 7 hundredths. So 2.37 I think would be a reasonable answer for this particular number line right here. I'm going to end this video here. Go ahead and continue on with the second video as soon as you're ready. Thank you.